All right, so we're gonna finish our 5.5 notes today. And Alpha did a really good job with it, so I bet you guys are gonna also do a really good job with this. Remember that we'll have a quest on 5.5 and 5.6 right before spring break. I believe it's that Wednesday, we'll have that quest. And I think that you guys generally do really well with these sections, so that's a really awesome way to start your fourth quarter grade. Okay, so we just kind of review what we did yesterday in class. We learned law of signs, which if this is not on your identity sheet, make sure it gets there. I'll write it several more times on the notes, so you can just make sure it gets there eventually, but law of signs should go on your identity sheet. What I did on the whole first page is I gave you two angles and a side, and then we often found the third angle, and then we used the law of signs to find the two other sides that we needed to find. Okay, so there's a lot of finding sides and angles, and on all of these, I gave you two angles and a side, two angles and a side, two angles and a side, two angles and a side. Okay. Now we're gonna skip number 2 still. We're gonna go do some word problems because we did, I think, the 2 harder word problems. I think to kind of get our brain back situated on law of signs, I want us to come down and do number 5. Let's do that word problem first, and then we'll come and do some new stuff. Okay, so it says 2 lighthouses A and B are known to be exactly 20 miles apart. So I'm going to give us that 20 miles apart is how far A and B are from each other. A ship's captain at point S measures ASB to be 33 degrees, so that's 33 degrees. And a radio operator at B measures angle ABS to be 52 degrees. Then it says find the distance from the ship to each lighthouse. So we're looking for this distance, we'll call that one X, and we'll call this one Y. Okay. And now we're just going to do basic law of sign, okay? What did we find first on all of the other things? What do we do first? Yeah, Megan? Find that third angle. Good. So I know this is 52. I know this one's 33. We want to find this angle up here by taking the 2 angles we know and subtracting from 180. So I'm going to think about X plus 33 plus 52 equals 180. Actually, a better thing to write might be A. And you don't even have to write this out nicely like this. You can just kind of do this in the calculator or off to the side. So when I add 33 plus 52, that's 85, and I minus that from 180, and I get 95. So this angle up here is 95 degrees. We didn't necessarily need to do that to find the first thing. And now I don't care if you find X or Y first, but you have to find both of them. They are independent of each other, so it doesn't really matter the order. I'll probably find X first. I'll talk through the first one and then I'll be quiet for you to do the second one. So I'm going to say sine of 33 over 20 is equal to sine of 52 over X. Sine of 33 over 20 equals sine of 52 over X. Cross multiply. You guys were really good at this the other day. X sine of 33 equals 20 sine of 52. And then we divide by sine of 33. So X is equal to 20 times sine of 52 divided by sine of 33. Get my calculator up to do that. Make sure you guys are also practicing plugging it in because it's not hard, but if you don't know how to plug it in, it's going to make the rest of this whole paper, worksheet, etc. much harder than it has to be. Okay. All right, so I got 28.9 for X. Why don't you take a minute, go ahead and find Y. I'll put my work up on the board so you can see it in this. Got my equation on the board. I'll keep solving it. Ooh. Well, I got 36.6 is my answer. Is that what you guys got? If you're plugging it in right, but you're not getting the right answer, make sure your mode is in degrees, because all of these angles are degrees. If you need to, you can always type 20 sine 95, enter, and then do divided by sine 33. If you have trouble getting the right answer, just let me know. Anybody questions on that word problem? That's kind of a nice review of all the things that we've done before. Nothing has been new yet, okay? Now we're gonna flip back to number 2, and now we are gonna do something new. Are you guys ready for something new? Okay. Number 2's directions say something different. It doesn't say solve the triangle. It says how many triangles are possible. Right now, we are going to do something called the ambiguous case. Let me try and write even nicer. Ambiguous case means we don't know. It's ambiguous. It's a little vague. We don't really know what's going on. The ambiguous case comes if I give you an angle and 2 sides. Remember, we can't write that on our paper, right? I had you in geometry a long time ago, but when we were proving triangles are congruent, I said you can't write ass forward or backwards or left or right or any direction on your paper. So that's why this is the ambiguous case, is because we have ASS. That's a problem. Okay, if I give you one angle and 2 sides, we technically have 3 things that can happen. We could have 0 triangles are possible from this. We can have 1 triangle is possible, or we could have 2 triangles is possible. Essentially, being just given an angle and 2 sides, that's not enough information to know what's going on in my triangle. What I gave you before, 2 angles and a side, was fine. But 2 sides and an angle that's not included in between those sides, that's a problem. Okay. So what we are going to do here is, if we have a triangle or 2 triangles, we're going to solve them. But we're going to do law of sine. And once we get law of sine, we're going to do like a quick team timeout. We're going to do a little stop and check something to see if we have 0, 1, or 2 triangles, okay? I have 3 examples here. If I were a betting person, I bet we'd see 1 of each example. Does that sound good? Let's do the first one, okay? So I'm going to draw that out. I'm going to draw this triangle, just a little example. A, B, C. We're going to say angle B is 82. That was given to us. Little b is 17. And then little c is 15. Big B and little c, which means that when I do law of sine, which angle am I about to find? Am I going to find A or C? C. You have to match them up. I know nothing about A. I don't know big A. I don't know little a. I don't know anything about A. So I have to do B's and C's, okay? So we're going to start by just doing our law of sines. We're going to just act like everything's normal. Going great. We're going to do sine of 82 over 17 equals sine of big C over 15. Okay, cross multiply and solve. I get 17 sine C equals 15 sine 82. I'm going to divide by 17. And I kind of left a little space as just being a little dramatic, because in order to get rid of the sine on both sides, I need to multiply both sides by sine to the -1, or I need to do the inverse sine. So it's not I'm multiplying, it's just doing the inverse sine will get rid of the sine on the left-hand side. It will leave C all by itself. And then this is what I'm going to plug into the calculator. I'm going to press second sine, 15 sine of 82 divided by 17. And you should just be able to type that straight across. I do put some parentheses when needed. I close them up if I was done with an angle, but I put everything together and I solve and I get 60.9 degrees. What that's saying is that angle C is going to be 60.9 degrees. However, I kind of told you that once we do our first law of sines, we're going to do a team timeout. We're going to stop and check something, okay? So we're going to stop and we're going to check. What we're going to check is if the supplement of the angle we just found also works. We're gonna see, we're gonna check, I just write the supplement. Now, supplementary is a word we use a lot in geometry. If I do 180 minus the angle given to us, that is the supplement. So we're gonna do 180 minus 60.9. We're gonna see what we get. And I get 119.1. What I'm gonna check is, could I possibly have 119.1 be that angle instead of C? So I'm gonna draw a new triangle and I'm gonna make C an obtuse angle because that's what 119 would be, right? We'll keep that A, we'll keep that B, we'll keep that C. If everything else is true, if angle B is still 82 and little b is still 17 and little c is still 15, could C be 119.1? Now, your question to me might be like, how do I know if this triangle makes sense? Like, I drew it and I labeled it. How do I know if it's true? My question to you is, how much should all the angles in the triangle add up to be? 180. So I'm going to add the two angles that I have that I think are true. I'm going to add, okay, 82 plus 119.1. And I get 201.1. Could I have a triangle with two angles that are 82, 119.1, and then have room for angle A? No, this is bigger than 180. So this triangle does not work. This is not a true triangle. That cannot happen. We had to check though, but there is not a second triangle here. However, the blue triangle is still good. We're allowed to have the blue triangle, but in this case, we just did the first, or we did the one triangle possible. That is what's true here. We do at least have one because I got an answer for my C, but I don't have a second one because I tried its supplement and its supplement does not make a true triangle. So I only have one triangle. Now, though, it does say once I figure out how many triangles it is, it does say solve them. So we are going to finish solving this triangle. I'm going to zoom back in on the blue guy. I think we can figure out angle A really easily. Can you help me find angle A? What are you going to do to find angle A? Good, and then 180 minus that number. So I added the two angles I had minus it from 180. Angle A is going to be 37.1. Makes sense. All three of those add up to 180. And then we need to find little a, and we can just do that using the law of sines that we have been doing. I am probably just going to keep using 82 and 17 because there's no decimals there, but you are welcome to do 60.9 and 15. So I'm going to do sine of 82 over 17 equals sine of 37.1 over little a. But if you want to use the other angle at its side, you're welcome to do that too. So sine of 82 over 17 equals sine of 37.1 over little a. You guys okay with that? All right, you're quiet. You guys are probably solving it because you guys were so good at this yesterday. A times sine of 82 equals 17 times sine of 37.1. Divide by sine of 82. Let's see. And 17 sine 37.1 divided by sine of 82 is, whoa. Oh, I don't know how that four got up. Sorry. 17, let's try again. 17 sine 37.1 divided by sine of 82 is, okay, that looks better, 10.4. Is that what you guys got? 10.4. The only thing that we had to do funny this time was that once I found that first angle, I just had to stop and check to see if its supplement worked. Okay, that's the only thing I'm teaching you new here. Okay. Should we do the next example? Okay. It says angle A is 73, little a is 24, and little b is 28. So let's draw a picture. A, B, C. Little a is 24 and big A is 73, and then little b is 28. Okay. Which angle am I going to find this time first? B. Very good. B is in boy. So just like we did before, we're going to go do our sine of 73 over 24 equals sine of big B over 28. Cross multiply, I get 24 sine B equals 28 sine 73. Divide by 24. And then I'm gonna do inverse sine on both sides to get rid of the sign on the left. So sine to the -1 and then sine -1. And so that's what I'm gonna put into the calculator. I'm gonna do second sine 28 times sine of 73 divided by 24. Right? Okay, that looks right. You guys get what I got? Mine says non-real answer. Did anyone get an error message on their calculator? Because that's right. You should not get an error message for this one. I'm gonna go on just to make sure. You got an error. Does yours say you just error on your calculator? Yeah. So if you mine, I don't know why mine says non-real answer, but you should get some kind of error message. That means that this does not exist. There's no angles that will make this true. There is nothing. So do I have 0, 1, or 2 triangles here? 0. This triangle doesn't work. This is not true. This will not work. And I'm actually done because I don't have any triangles to solve. That is 0 triangles. So actually getting 0 as an answer is kind of fun because then I'm just done. All right, that's it. We can move on. All right, this last example, what do you think is going to happen? Yep, Charlie, you're so right. We're going to do 2 this time. So it's nice to kind of know that that's happening. We're probably going to have 2 triangles on this one. So I'm going to do the same thing that I did before. However, I am going to draw the shape. Let's see. I'm going to label, I'm going to label C down here, and I think A up here. Nope, I lied. I still want A over here. Did I do that wrong? That's close. It doesn't really matter. It doesn't really matter. If I need to change it, I will. But there's one way that I can draw it that will make the most sense. Now that I'm overthinking them, I'm still afraid I'm doing it wrong, but that's okay. Maybe I'll just switch A and C. That's what I want to do. Yeah, go. I'm going to switch A and C. I think that will be what I want it to be. So I labeled C as like my little left side angle. 10 is across from 32 angle C. 18 is across from big A. And I don't know big B or little b or big A. So again, just like we've been doing, I want to do start with my law of sines. What angle am I going to find first? Big A. So we're going to go set that up. Sine of 32 over 10 equals sine of big A over 18. Cross multiply, I get 10 sine A equals 18 sine 32. Divide by 10. Sine A equals 18 sine 32 over 10. And I am going to do my second sine, my inverse sine on both sides. So in the calculator, I'm gonna press second sine 18 sine 32 divided by 10. All right, cool. Did you guys all get 72.5 as well? Now, that is the answer we got. So I'm gonna write 72.5 in here. But remember, like the last one, when you get an answer, you need to team time out, you need to stop, you need to check and see if its supplement works. So we're gonna check now the supplement. So I'm gonna do 180 minus 72.5. Which is gonna be 107.5. That alone does not tell me anything, okay? Now I'm gonna redraw this picture. So I was kind of being weird about drawing this picture earlier because I was trying to be intentional and make this a helpful picture. So that's why I flipped C and A, because I want C to stay where it was. I want it to be 32. I want the 18 to still be in between C and B. I want 10 to still be in between A and B. But instead of angle A being that 72.5, let's see if its supplement will work. Let's see if 105 or 107.5 works in that spot. Okay, so we're gonna add them together, 32 plus 107.5, and I want that to be less than 180 so I can make a second triangle. But if it's more than 180, it doesn't work. Okay, so 107.5 plus 32. Ooh, that's less than 180. That means that I have room for another angle, right? I have a measurement for angle B. I can do that 139.5 subtracted from my 180. So that means this angle would be 40.5. Does that triangle exist? Yeah, we just found it, right? All the angles out of 180. So now this is an example where I have two triangles. I have a blue triangle where angle A was exactly what we found it to be. Oh, let's figure out what angle B is if angle A is 72.5. So 32 plus 72.5 is a 104. 180 minus 104.5 is 75.5. So in one of my examples, angle A was 72.5, which makes angle B 75.5. And in the other triangle that also works, angle A is 107.5 and angle B is 40.5. In both of these, we want to find out what little b is. So we're going to do two more law of sines to figure out what little b is, okay? So I'll keep it color coordinated. I'll do the blue triangle in blue and I'll do the red triangle in red. I am probably going to keep doing the two that were fully given to us. So when I do the blue triangle, I'm probably going to say sine of 32 over 10 equals 75.5 over little b. And then in my red triangle, again, I'm going to use the ones that were given to us. Sine of 32 over 10 equals 40.5 over little b. So I make sure all my equations are set up right. Go cross multiply and solve. B sine 32 equals 10 sine 75.5 divide by sine of 32. 10 sine 75.5 divided by sine of 32 is 18.3. 12.3. So we had to solve for all of them. What you guys got for those? All right, that is it for 5.5, but I want to give you a couple identities and do a tiny bit of the first problem of 5.6. So we've got less to do later, okay? Does anybody have any questions on what we just did? Okay, when you're ready to move on, I want you to pull your identity sheet out because we're going to add two more things on it. We're going to add logs, cosines, and we're going to add area of a triangle. So I'm going all the way to 5.6. I'm just going to write mine on the top here. What's the sum of all this here? All right, so just a reminder, you guys should already have log signs on your paper, right? I'm just gonna rewrite it just in case you don't. Sign of A over little a equals sign of big B over little b equals sign of big C over little c. You guys have been rocking that. Now what we're about to do is called law of cosines. And I'm gonna write three equations here. It's the same thing, just kind of over and over and over, okay? This one looks different. It's not a fraction, so I'd maybe watch me write it all the way out before you write it down. It goes a squared equals b squared plus c squared minus 2 times b times c times cosine of a. You can put little multiplication signs in there if you like. I want you to note that whatever is being squared, the side that's being squared on the left side of the equation by itself is the same as the angle that you're doing the cosine of. I'm going to write two more equations, but it's basically that just kind of manipulated around. So I've got B by itself and I've got C by itself. So the next one, I'm going to do the exact same thing. I'm just going to go B. I'm going to say B squared equals A squared plus C squared minus 2 times A times C times cosine, this time of big B. And then last but not least, I'll do it with C all by itself. So C squared equals A squared plus B squared minus 2 times A times B times cosine of C. We're going to use that in a second so you can kind of see what I'm talking about with that. The other thing I do want you to write, just because of, just so we don't have to write anything on our identity sheet tomorrow, is area of a triangle. You're probably like, well, I know area of a triangle is 1/2 base times height. You are correct, but in this case, we're also going to think about area of a triangle equals 1/2 AB sine C. AB sine C. We're not going to do area of a triangle today, but I do want to do one quick law of cosine. All right, so this first problem, I'll kind of keep it so you can kind of see what's going on still. It says solve triangle CHS. That looks exactly like the same directions of what we did in 5.5, but notice, if they could let me teach
please
the
excuse
whole
the
note.
interruption. 310, and you were just sent a survey for feedback on today's speaker. So teachers, if you have the opportunity to let students do that for a minute or two,
Let me have the
it
opportunity
would be
to
much
class.
appreciated.
That would be nice.
And we'll be back in a few minutes with the end of the day prayer. Thank you.
Let me at least set this up and then you can take your survey. I just like, why am I not? So, what's going on here is that I am giving you an angle and two sides like last time, but you notice how it's a side, and then the angle is in between the other side. So this is actually side, angle, side. If you remember that from our congruent triangles in geometry, we did SACs. So side, angle, side, that means to me that we're gonna go do a law of cosines, okay? I am going to use C is going to be my angle that's at the end, so that means little c is gonna be what's by itself on the left-hand side. So we're just gonna plug in, we'll say 10 is A and we'll call 12 B, and we're just gonna plug it into that equation. So we'll say C squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times cosine. And I actually know what C is, so I'm gonna use cosine of 58. We can do a quick plug and chug in the calculator, because I think you guys can do all of this even without me instructing you. I'm always really cautious, so I'm probably gonna do these squared by themselves. So I've got 10 squared is 100, 12 squared is 144, and I'm gonna go throw all of that into my calculator at once. So I'm gonna do 2 times 10 times 12 times cosine of 58, and that gets me 127. I did not do anything to that negative sign, so I do need the negative to go down, so it would be minus 27.2. I'm gonna combine all three of those terms. 100 plus 144 minus 127.2. And then what am I gonna do to finish this problem off? Square root, good, square root that. And so C is gonna be 10.8. We will finish solving that on Monday, but I wanted to do a quick law of cosine for you guys to have some value with it. You do have 5.5 due next class, and if you want to take a minute and do that survey, that's great. Any other big questions for me? From you all.